stars, they were looking at something fundamentally alien in its chemistry, something that might rewrite what we know about the building blocks of other planetary systems. As astronomers measured the composition of 3I Atlas, they quickly realized the scale of its outgassing was far beyond anything they expected. The carbon dioxide wasn't just present in unusual amounts. It was forming a vast, expanding cloud around the object, a coma so large it defied comparison to most comets we've seen before. Observations revealed that the gas cloud stretched out an incredible 300,000 kilometers in radius. To grasp that size, imagine a sphere larger than the distance between the Earth and the Moon. It meant Atlas wasn't just venting, it was spewing material into space at a level that made even our largest comets seem modest. This raised a critical question. How big was the object hiding inside that glowing veil? The nucleus, the solid core of rock and ice that drives a comet's activity, could not be seen directly, cloaked as it was in its bright coma. But by studying the density and extent of the gas cloud, scientists estimated the central body might be as large as 46 kilometers across. That is staggering. For comparison, Comet Halley's nucleus is only about 11 kilometers wide. The famous Comet Hale-Bopp, one of the brightest in modern history, had a nucleus roughly 60 kilometers across. If the estimates hold true, Atlas could rival the largest known comets ever observed. And yet, it is not even from our solar system. It comes from the depths of interstellar space. The implications are enormous. A nucleus of that size, shedding carbon dioxide at such intensity, would contain vast reservoirs of frozen material. It would mean Atlas carries with it a record of conditions in its birth system, preserved across billions of years, and now drifting through our cosmic neighborhood. But there is another possibility that unsettled some researchers. What if the nucleus isn't actually that big? What if instead, Atlas is simply unusually active, expelling material at rates far beyond what we'd expect for an object of its size? That could mean the estimates of a 46-kilometer nucleus are misleading, and the true body inside might be smaller, behaving in extraordinary ways. The truth may only be revealed as Atlas moves closer to the Sun, where its activity can be tracked more precisely. But even now, the sight of such a massive CO2-dominated cloud has sparked new debates. Why is it so large? What keeps the gas flowing at such intensity? And is this sheer scale another sign that we are dealing with an object unlike anything born in our solar system? Some even took the speculation further. If Atlas were artificial, or at least engineered in some way, then a massive, bright coma could serve a purpose, like a shroud masking what lies beneath, or even a form of propulsion, dispersing gases in controlled bursts. While such theories remain on the fringe, they underline how unsettling this discovery was for many who expected Atlas to behave like a normal comet. For now, what can be said with certainty is this: 3I Atlas has the largest, most dramatic coma of any interstellar visitor we have ever studied. Its enormous CO2 cloud makes it not just another icy traveler, but one of the most spectacular and puzzling objects astronomers have ever set their sights on. As if Atlas had not already shattered enough expectations, one more discovery left scientists scratching their heads. Using the immense power of the European Southern Observatory's Very Large Telescope in Chile, astronomers probed the composition of the gases flowing out of its coma. What they found was astonishing. Spectral analysis revealed the presence of nickel, one of the heavier elements usually locked deep inside rocky material. Detecting nickel in a comet is rare but not unheard of. Astronomers have observed it in certain long-period comets within our own solar system. But in those cases, nickel almost always appears alongside iron, its chemical twin. The two elements are bound together in most natural processes. They form under similar conditions, and when one is present, the other almost always follows. But not with 3I Atlas. The data showed nickel, but no trace of iron at all. It was like finding salt without pepper, or thunder without lightning. The absence of iron made no sense. Where had it gone? How could nickel exist in isolation? This finding forced scientists to consider unusual possibilities. One idea is that Atlas formed in a region of its home star system with highly specific conditions, perhaps temperatures and chemical balances that allowed nickel to condense while iron did not. But that scenario would be extraordinary, requiring an environment unlike anything we have documented in the birthplaces of our own comets and asteroids. Another possibility is that Atlas once contained both nickel and iron, but something in its long interstellar journey altered its chemistry. Maybe cosmic rays or repeated heating cycles stripped away the iron, leaving nickel behind. But again, this explanation is hard to reconcile with what we know of metal stability in space. Of course, once again, speculation ran wild outside mainstream circles. Some suggested that the selective presence of nickel without iron might be the result of a refining process, something deliberate, like smelting. On Earth, when we separate metals for use in technology, we often end up with one material in higher purity than the other. Could Atlas be showing the fingerprint of an engineered object rather than a natural one? Most scientists remain cautious, but even the most skeptical voices agree. The nickel discovery is one of the most puzzling aspects of Atlas so far. It is a clear chemical anomaly, one that cannot easily be explained away as a trick of light or perspective. The bigger picture is this. Every time researchers peel back a layer of Atlas's mystery, they find something that doesn't belong, something that challenges our assumptions about how comets should behave, what they should be made of, and where they should come from. Nickel without iron is just the latest reminder that Atlas is no ordinary wanderer. It is an object that seems determined to rewrite the rulebook of planetary science. By the time Atlas revealed its strange behavior, the sunward tail, the carbon dioxide dominance, the vast coma, and the nickel without iron, scientists and the public alike were running out of familiar explanations. Nature seemed to be breaking its own rules, and whenever that happens, the human imagination begins to wander into extraordinary territory. And so the question was asked, quietly at first, then louder in late-night discussions and online forums, what if Atlas isn't a comet at all? Some theorists began to speculate that this mysterious object could be an alien probe, moving deliberately through interstellar space. The unusual tail pointing toward the sun was cited as possible evidence of propulsion, gas being vented in a controlled way, like the exhaust of an engine. Others suggested that the overwhelming carbon dioxide emissions could be part of a design, a system of thrust, or even camouflage, making the object appear to be just another comet, when in fact, it is something far more advanced. Another idea was even more radical, that Atlas could be a giant life form, a kind of organism that survives by drifting between star systems. In this view, the carbon dioxide emissions might not be exhaust or ice sublimation, but the metabolic activity of a creature unlike anything we could imagine. Its coma could be seen as a protective shell, or even as a way to interact with solar energy in a manner similar to photosynthesis. While highly speculative, such ideas reflect just how alien Atlas's behavior appears when compared to known comets. Third camp leaned toward the concept of Atlas as a CO2 venting spacecraft, a megastructure built by an advanced civilization, perhaps as a way of traveling between stars. To them, the nickel detection without iron was not just a chemical curiosity, but a possible signature of technological refinement. The way humans process metals for specific uses, of course, mainstream scientists remain cautious about all of these theories. The vast majority emphasize that extraordinary claims require extraordinary evidence. While Atlas is undeniably strange, it is still more likely to be a natural object with unfamiliar chemistry and physics than an engineered craft or alien organism. History has shown that when the universe surprises us, the explanation is usually exotic but still natural. Yet, it is also true that we are living in an era where the search for extraterrestrial intelligence is no longer taboo. Missions like Breakthrough, Listen are actively scanning the skies for signals, and the possibility of interstellar artifacts has been openly debated since Oumuamua's flyby in 2017. Against that backdrop, Atlas has become the perfect canvas for our hopes, fears, and imagination about intelligent life beyond Earth, whether a probe, a life form, or simply a comet that breaks the mold. Atlas has forced us to confront how little we truly know about the galaxy. It reminds us that when something from beyond the stars enters our solar system, it may not fit neatly into the categories we've built from studying our own backyard. And that uncertainty, that crack in the door of the unknown, is enough to keep the alien question alive in the minds of many. For all the mystery surrounding 3I Atlas, one of the most exciting opportunities to study it is coming very soon. In early October 2025, the object will make its closest approach to Mars, passing at a distance of about 28 million kilometers. That may sound vast, but in astronomical terms, it is a close encounter, close enough that spacecraft already orbiting Mars will have a chance to turn their cameras and instruments toward this interstellar visitor. 2. Spacecraft in particular are poised to play a key role: ESA's Mars Express and the ExoMars Trace Gas Orbiter. These missions were never designed to study comets, let alone interstellar ones. Mars Express has spent over 2 decades mapping the Martian surface and atmosphere, while ExoMars focuses on detecting trace gases that could reveal geological or biological activity on the red planet. Yet both carry cameras and spectrometers capable of capturing valuable data on Atlas. Scientists are eager for this chance because most of our current observations come from Earth-based telescopes. While powerful, those instruments are still limited by distance and atmospheric interference. A view from Mars' orbit would provide a completely new vantage point, one not filtered through Earth's skies, and one far closer to the action. Even a handful of images could reveal details about the coma's structure, the orientation of the tail, or sudden changes in brightness that might otherwise be missed. There is also the possibility of catching Atlas in transition. As it approaches perihelion at the end of October, its activity may ramp up dramatically, releasing even more carbon dioxide and potentially reshaping the coma. A Mars flyby happening just weeks before that moment is a rare stroke of timing, a chance to watch Atlas as it gears up for its closest pass to the Sun. For mission planners, the challenge will be squeezing in the observations. Both Mars Express and ExoMars already have packed schedules, focused on their Martian science goals. But the scientific payoff of turning their gaze outward, even briefly, is enormous. This is only the 3rd interstellar object humanity has ever seen, and the first to come within observational reach of active spacecraft. Passing up the opportunity is unthinkable. The data collected in October may not answer all the questions about Atlas, but it could give us the clearest look yet at the strange chemistry and structure of this object, helping confirm or challenge the puzzling findings of Earth-based observatories. And beyond that, it is a reminder of how fortunate we are. Interstellar visitors are vanishingly rare, yet here we are, with spacecraft already in place to meet one as it sweeps past a neighboring world. It is moments like this that make planetary science feel like detective work. We may not know what Atlas truly is, but every new perspective, every new observation brings us closer to solving the mystery. And the upcoming Mars flyby could be one of the most important chapters in that search. While the October flyby of Mars promises exciting close-up observations, 3I Atlas's journey doesn't end there. In fact, the object will continue its rapid trek out of the inner solar system, and the next major opportunity to study it comes in March 2026. On March 16, 2026, Atlas will pass within 53 million kilometers of Jupiter, bringing it close enough for one of our existing spacecraft in the Jovian system to potentially get a glimpse. That spacecraft is NASA's Juno probe, which has been orbiting Jupiter since 2016. Originally launched to study the gas giant's atmosphere, magnetosphere, and internal structure, Juno has exceeded expectations in both longevity and scientific output. However, its main mission was scheduled to conclude in September 2025, with plans to deorbit the probe into Jupiter's atmosphere to avoid contaminating the planet's moon. Now, Atlas presents a tantalizing alternative. Mission planners could consider extending Juno's life slightly, redirecting its instruments to observe this interstellar visitor as it passes by the giant planet. Even at 53 million kilometers away, Juno could provide unprecedented data, high-resolution imagery of the coma, measurements of its composition, and detailed tracking of its trajectory. For the first time, we might observe an interstellar object with a spacecraft actually within the solar system, rather than relying solely on telescopes from Earth or Mars' orbit. The potential scientific payoff is enormous. Observing Atlas from Juno could help refine estimates of the nucleus size, analyze the behavior of its CO2-rich coma, and even offer insight into the peculiar nickel signature detected back on Earth. It may also help confirm or refute some of the more speculative theories, showing whether the sunward tail or unusual emissions have natural explanations or something more mysterious. Of course, extending Juno's mission is not without risk. The spacecraft is aging, and fuel and instrument limitations are serious considerations. But scientists are weighing the opportunity against the once-in-a-lifetime nature of this encounter. Interstellar objects are incredibly rare. The chance to observe one from a spacecraft already in place in the outer solar system is almost unprecedented. Beyond the science, there is a sense of wonder and urgency. Atlas is a traveler from another star system, moving so fast that every opportunity to study it must be seized. By the time it passes Jupiter, it will be on its way out of the solar system, never to return. If Juno or any other probe can capture even a few images or measurements, it will add critical pieces to the puzzle of what this alien object really is. In that sense, the March 2026 TESS Jupiter encounter is more than just a waypoint. It is a chance to push the boundaries of our knowledge, to study an interstellar visitor with tools humans have already sent far across space, and to witness in real time the fleeting passage of something both alien and magnificent. Atlas is reminding us that the universe is vast, mysterious, and sometimes, just for a brief moment, it comes close enough to say hello. Atlas has already challenged everything we thought we knew about comets and interstellar objects. From its early brightness beyond Jupiter, its sunward-pointing tail, the massive carbon dioxide coma, and the unusual nickel without iron, to the tantalizing possibilities of alien origins, it has kept astronomers and enthusiasts alike on the edge of their seats. Yet, despite all the observations, so many questions remain unanswered. What exactly is at the heart of Atlas? How did it form? And in what kind of star system? Could there be natural explanations for its strange chemistry and behavior? Or is there something more extraordinary at play? The opportunities to study it, from the upcoming Mars flyby to the potential Juno encounter at Jupiter, offer humanity a fleeting chance to uncover these secrets. But no matter what we learn, Atlas reminds us of the vastness of our galaxy and how little we truly understand about the objects traveling through it. In the end, 3I Atlas is more than just a comet, a chunk of ice, or an interstellar wanderer. It is a messenger from afar, carrying clues about distant worlds and alien systems, and a reminder that the universe is stranger, more complex, and more fascinating than we could have imagined. As it continues on its journey out of our solar system, one thing is certain: the story of 3I Atlas is far from over. And as we follow it across the stars, we are witnessing a rare and extraordinary encounter with the unknown. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.